Hey everyone, and welcome to this explainer from Forge College. I'm super excited to guide you through today's topic, which is designing a robust program entry point. If you've been following along in our Programming with Solana track, you know we've been building up to this. This lesson builds perfectly on our previous chat about security and debugging strategies for entry points, where we looked at defensive checks and early rejections. Well, today we're taking those raw security concepts and really formalizing them into a rock-solid mental model. We want your program's entry point to handle instruction parsing, data layout, and client interactions without even breaking a sweat. So if you've ever felt kind of lost about where exactly to put your validation logic or how to properly format your data for borsh-serialization, you are definitely in the right place. All right, here is our roadmap for this explainer. First, welcome to the entry point. Then, checkpoints and dispatchers, parsing and data layout, defining validation boundaries, building a stateful counter, and finally, next steps and recap. Let's jump right in.
Okay, to make this whole concept super intuitive, we're going to use a metaphor. Imagine your Solana program is the absolute hottest, most exclusive VIP nightclub on the blockchain. Your entry point, that's the front door. And right at this door, you've got two critical staff members, a lightning-fast, incredibly strict bouncer, and a highly organized host. The bouncer acts as your secure checkpoint. They don't care about your life story, right? They just want to see your ID, check if you're on the list, and make sure you aren't wearing sneakers. Then, right behind the bouncer is the host, or the dispatcher. Once the bouncer actually lets you in, the host looks at your ticket and routes you to the exact table or dance floor you belong to.
So let's move into section 2 and take a closer look at these checkpoints and dispatchers. This table brilliantly lays out exactly what our bouncer is doing at that checkpoint. Look at these concrete checks. First up, the instruction discriminant. The bouncer just reads the very first byte of data. If it's an unknown ID, you're rejected immediately. No VIP ticket, no entry. This is huge because it prevents the program from wasting our precious compute budget trying to deserialize a bunch of garbage data. Next is basic syntax. Is the instruction data actually the right length? If not, we fast fail, no questions asked. Then account meta presence. We're checking that the required accounts actually exist at the indices we expect, which totally saves us from catastrophic panics later on inside our handlers. And finally, signer and ownership flags. If an operation requires authority, the bouncer checks for that signature right at the door. All of these are incredibly rapid, low-cost checks that happen before anyone even sets foot inside the club. All right, moving right along to section 3, parsing and data layout.
So we mentioned the instruction discriminant a second ago, but let's actually define it. Think of it as your VIP ticket. It's typically a compact 1-byte ID badge that gets read at the checkpoint. This single byte is a fully deterministic, minimal first step in our parsing strategy. By just reading that very first byte, the dispatcher knows exactly which handler to call and which payload layout is coming next. It's explicit, it's minimal, and honestly, it is incredibly efficient. Now, once the dispatcher knows where to send you, we have to actually deserialize the data. And here is the golden rule for borsh-serialization. Explicit, fixed-size structures will make your life infinitely easier. When you're designing your account state layout, you really want to favor fixed-sized fields, things like U64, fixed-sized byte arrays, and pub key. Why? Because it makes size calculations and rent checks completely predictable. It saves you and your users money. Both your Solana program and the client-side app will agree exactly on the binary shape of the data. Zero guesswork involved.
But hey, let's be realistic here. Sometimes you just can't avoid variable length data, right? Maybe you need to store a string or a dynamic list. If you absolutely have to use variable length data, you must establish a maximum limit, period. You encapsulate it in a vector or a string with a strict, rigidly enforced maximum length. If you skip this step, your program could hit unexpected off-bytes errors during deserialization, or worse, a user might accidentally bloat an account way beyond its rent exemption. Always, always bound your data clearly. Which brings us nicely to section 4, defining validation boundaries. So looking at this breakdown on the left, we have the entry point, our bouncer. Their entire job is syntactic validation, checking discriminants, data lengths, account presence, signer flags. It's binary, it's fast, yes or no, basic integrity checks. Then over on the right, we have the handlers, the managers of the club. Their job is semantic validation. They deal with the deeper, much more complex business rules. They ensure semantic consistency between multiple accounts, validate cross-account state transitions, and check those complex domain invariants.
By splitting these duties up, our entry point stops malicious inputs early and cheaply, while the heavy business logic is kept safely inside the focused handlers, where you actually have the rich context needed to make those decisions. Now, you might be wondering, hey, why not just do all the validations right at the entry point? Just let the bouncer handle the whole shebang. Well, duplicating your domain checks at the entry point creates an absolute maintenance nightmare. Plus, it wastes resources. Think about it. If the bouncer is trying to balance the nightclub's ledger while also checking IDs, that line out front is literally never going to move. We always want a single authoritative place for each type of validation. Syntactic checks at the door, semantic and variants inside the handlers. That way, when you need to update a business rule later, you only change it in one highly localized place.
Okay, let's put all this into practice in Section 5, building a stateful counter.
Here is the exact step-by-step flow your program needs to follow. Step 1, read the discriminant byte. Step 2, match that byte to the expected variant and deserialize the payload. Step 3, validate that the required accounts exist at the exact positions you expect them to. Step 4, check those signer and owner flags for the authority account. Boom, the bouncer's job is done. Then, Step 5, the dispatcher steps in and calls the handler, passing along the deserialized arguments and the sanitized account slice. And finally, Step 6, the handler performs its deep domain checks and safely mutates the state. It is just a beautiful, highly predictable pipeline.
And regarding client expectations for this counter program, we set up a very strict blueprint. The client absolutely must send the state account as account 0 and the payer or authority as account 1. Then, take a look at our fixed size state header here. A U8 for the version, a pub key for the owner, and a U64 for the counter. It is entirely fixed size. This ensures that rent and memory allocation are completely predictable, completely removing any ambiguity when a client tries to interact with our program. All right, as we close out the VIP club for the night, let's hit our next steps and recap in Section 6. If you take nothing else away from this explainer, please keep these 3 guiding principles in mind. Number 1, treat your entry point as a fast checkpoint with an organized dispatcher. Don't mix your business logic with your routing. Number 2, always choose a deterministic, borsh-friendly data layout. Favor those fixed-sized fields and explicitly bound any variable length data. And number 3, draw crystal clear validation boundaries. Stop malformed packets right at the door and let your handlers deal with the complex domain invariants. Sticking to these 3 principles will guarantee your entry point is robust, secure, and ready to play nice with any client application. And that actually leads to this incredibly important realization. Creating a minimal client interaction surface massively reduces integration friction. By explicitly documenting your required accounts, the exact discriminant bytes, and the borsh payload layout, the client knows exactly what to assemble and send. You eliminate all the guesswork, and that means fewer bugs, way easier unit testing, and just a much smoother experience for anyone building a front end for your Solana program.
So, I'll leave you with this provocative thought. Every single time you write an entry point, you need to ask yourself, is my bouncer letting just anyone walk through the door with a fake ID? Because in Web3, a single bad parse can literally drain an entire protocol. Are your validations bounded tightly enough to tackle our next topic, implementing borsh-serialization for entry data? Keep these blueprints incredibly handy as you move to that next lesson in our Building Solana Program Entry Points module. Thank you so much for joining me for this explainer. And remember, head over to forge.college to discover more deep dives into Web3 development, access interactive exercises, and continue leveling up your Solana skills with Forge College. See you next time.